Hello, this is SreeKeshava, Assistant Professor, Jyoti Institute of Technology, Department of Civil Engineering. My topic is Introduction to Stress and Strain. This topic is prepared to aiming third sem civil engineering students, strength of material subject. The main learning objective of my topic is define basic properties of material, define load deformation on material or structures, identify different types of stress and strain. So basic properties of materials. So if you consider any material, we are assuming in strength of materials that it is homogeneous, isotropic and elastic. So my first basic property is homogeneous. What is meant by homogeneous? If you consider any material, the properties are of same type, then it is called homogeneous. So the first assumption of the SOM is it is homogeneous. Next, isotropic. It is another physical property and the whole physical property is same throughout in the material, then the condition is called isotropic. Elastic. So if you consider any material, it is subjected to loads, then the material will undergo deformation. So in the material, if you are applying the load, it will undergo deformation. If you are removing that load, it will bring back to its original shape. The nature of the material is called elastic. So it should possess elastic property. Next objective is load deformation of structure. Generally, all our structure or bodies are subjected to two types of loads. One is static, other one is dynamic. So both the types of load will result in four types of deformations: axial deformation, flexural deformation, shear deformation and torsional deformation. These four deformations are due to application of any kind of those two loads. So corresponding to these four deformations, we are having four strain components: so axial strain, flexural strain, shear strain and torsional strains, or combination of these fours. Corresponding to these four strains, again four stresses are developed, that is axial stress, flexural stress, shear stress and torsional stress. So those four stress and strains may be axial, shear, bending, torsion. These four stress and strains are due to application of loads. So first consider axial. In axial, we are having two types: tension and compression. So first I'm coming to stress. What does it mean by stress? Stress is nothing but, if you consider at any point, is defined as resistance developed per unit area. Similarly, the strain is a measure of deformation by the external force on it. It is defined as the ratio of change in length to the original length. So may be compressive or tensile. So next, if you're coming to shear. So shear stress are nothing but when the force applied parallel to the cross-sectional area, then the angular deformation in the material will occur. The resulting stress is known as shear stress. Similarly, the resulting deflection or displacement is known as shear strain. So if you come to bending, if you consider any member, horizontal member, you are applying a vertical load. So in the direction of the load, it will deflect. Whatever the force perpendicular to the member will create stresses in the member is known as bending stress. Similarly, the deformation or the displacement will lead to the bending strains. So finally, the bending stress and bending strain will due to the application of vertical loads. Finally, the torsion. So torsion is responsible with the load of rotating type. Rotating type of loads are responsible to create torsional stress or torsional strains. So if you consider a member is subjected to different types of loads, depending on the application of loads, we are getting different types of stresses and strain in the member. Thank you.